Okay, so let's have a look at the Leaving Cert Higher Level Maths Paper 1, 2019, question 8. Okay, so we have the weekly revenue produced by a company manufacturing air conditioning units, and they're saying that this is seasonal, which you'd imagine it would be. You'd sell more in the summer than the winter, I'd imagine, so it's cyclic kind of sales revenue. The revenue in euro can be approximated by this function here, which is a cosine function, and we have the revenue with respect to t here is equal to 22,500 times the cos of pi over 26 times t plus 37,500, and t is going to be positive here. T is the number of weeks measured from the beginning of July, and this value here, pi over 26 times t, is in radians, so you've got to just have your calculator set to radians doing this question. Okay, find the approximate revenue produced 20 weeks after the beginning of July. Give your answer correct to the nearest euro. So this is just a straightforward substitution kind of question. Let me just write it down first. Anyway, we have or t is equal to 22,500 times the cos of pi over 26 t plus 37,500. Now we want t to be 20. We're looking at the revenue produced 20 weeks after the beginning of July, and that's what t is. T is the number of weeks measured from the beginning of July. So we want or 20, so that's going to be 22,500 cosine of pi over 26 times 20, and then we've got to add 37,500. Okay, so this is just a straightforward calculator type problem. I mean, just type this into your calculator, add 37,500, make sure your calculator is in radians, and you should get 20658.51. This is going to be in euros. Now it says here give your answer correct to the nearest euro, so to the nearest euro this is going to be 20659 euros to the nearest euro. Okay, so that's part A done. Let's have a look at part B. Find the value of the time t within the first 52 weeks when the revenue is approximately 26,250. So this is the same kind of thing again, except this time we're given the revenue and we've got to work out what t is. So let's just write down the formula again. It's or t is equal to 22,500 the cosine of pi over 26 times t, and then we've got to add 37,500. Okay, so in this case we're given the revenue, so we're told the revenue is 26,250. So let's just write the rest down. 22500 cosine pi over 26t plus 37,500. Okay, so we've got to work backwards here to find out what t is. Now what I'm going to do here is subtract 37,500 from both sides first, and then I'm going to divide by 22,500. So that will leave me with cosine of pi over 26t on the right hand side. Remember, I've subtracted this and divided by this here. So on the left hand side what I'll actually end up with is minus a half. So we've got to work out what this is first or next. So let's just have a look at this. Really what we want to do is, if you like, find the cos inverse of minus a half. Now let's just have I'll just draw a quick diagram here first. Let's just draw the y-axis and the x-axis here. So we want the cos of some angle here in radians to be negative, and remember that we have this kind of idea here that all sine, cos and tan are positive in the first quadrant, sine is only positive in the second quadrant, tan is positive in the third quadrant, and cos is positive in the fourth quadrant. So remember, we want an angle. In fact, we want two angles here. We would need two values of the time t. So what we want here is to find two angles where the cos of these angles are negative. So we're going to be looking out here in the second quadrant and the third quadrant. So our two angles are going to be here and here. So now let's just look at what we call the reference angle here. So if I draw, let's say, this angle here, we look at one of them first. Our reference angle here, which we'll call alpha, let's say, is going to be the cos inverse of plus a half. So what we're going to do is find the cos inverse of a half. So the let me just work that out. Cos inverse of a half is going to be, if you look that up, it's one of these special angles. So the cos inverse of a half is just pi over 3. Since we're dealing in radians, so that's 60 degrees in degrees, but we're working in radians, so we'll stick with pi over 3. Now that means that our, this is gone here, so I'll just draw this again. So that means that our reference angle here, this angle in here, has to be pi over 3, and also in our third quadrant, this angle here has to be pi over 3. So I'll just put those in there. So this is going to be pi, this is going to be pi over 3 here, and it's going to be pi over 3 here. So that angle and this angle here are going to be pi over 3. They're not the angles we're looking for, they're just simply the reference angles. The actual angles that we're looking for are going to be this angle here, and also this angle here. So those two angles, when we find the cos of them, will give us negative a half, minus a half. So what's this first one here? So we'll call this the second angle. The first one here is going to be 180 degrees, if you like, which is pi. It's just going to be pi out as far as here. We've got to take away pi over 3. Well, in terms of pi over 3, pi is just 3 pi over 3. 3 pi over 3. We want to take away 1. We want to go back towards the positive sense of the x-axis, if you like. We want to go back this way, 1 pi over 3. So this angle here will actually be 2 pi over 3. Our first angle will be 2 pi over 3. So this means that this angle here, pi, let me just change that, pi over 26t is going to be equal to, what did I say, 2 pi over 3. 2 pi over 3. Also, we've got to look at this second blue angle here, this from here out to here. Now that's going to be 3 pi over 3 plus another pi over 3, so it's actually 4 pi over 3. So it's also going to be equal to 4 pi over 3. Okay, so these are our two angles where the cos of this particular angle here is negative a half. So now we've got to work out what t is in both of these cases. So let's do that. Now, let's see, we'll take this one here first. I might just write that in here. This is equal to pi over 26t, just to have the full equation on both sides here. So let's see, here I'm going to divide the left hand side by pi over 26. So that'll give me t is equal to 2 pi over 3. Now remember, if we were dividing by a fraction, we just flip it upside down and multiply. So I'm going to multiply by 26 over pi. On this side here then we just again divide by pi over 26, so that will give us t on this side is equal to our 4 pi over 3 multiplied by, now I'm dividing by pi over 26, so I'm going to multiply by 26 over pi. Okay, so finally then, or almost finally anyway, we've got t here is equal to, you can see here we've got on the top of this fraction here, we've got a pi which is multiplied, everything on the top is multiplied, everything on the bottom is multiplied, so that will go and that will go. Same here, these will disappear, or they'll divide to give us 1. So really what we end up with here is 2 times 26 divided by 3. 2 times 26, and on the bottom we're dividing by 3. So that'll give us 17. That'll give us 17 and 1/3. So it's 17 and 1/3 weeks. And on this side here we got 4 26s divided by 3, and that will give us here, and I write it this way, t is equal to 34 and 2/3 weeks. 34 and 2/3 weeks. Okay, and that's what we were asked for. We were asked to find t, I think, from what I can remember. Find the two values of the time t within the first 52 weeks when the revenue is approximately 26,250. So we're looking at 17 1/3 weeks and 34 and 2/3 weeks. Okay, so let's have a look at part C then. Part C is the next section here, so we've got to find r prime t. So in other words, we've got to differentiate this function here. So let's do that. So we're told that r of t here is equal to 22500 cosine, what have we got, pi over 26 t, and then we've got to add 37,500. Okay, so r prime t then is the differential of this right hand side here, so let's do that. Well, if we differentiate this bit out here at the end, we'll get 0, so we can forget about this bit here. So it's this bit here we've got to work on. So well, the 22500 will remain. Now we have a cos, we're differentiating cos, so if you differentiate cos you get minus sine. So I'm going to put the minus out here, and we'll put the sine. I'm just going to leave a little gap here because I know what's coming up. Sine pi over 26t. That's what you do initially, but because we don't have a cos of t here, we've got the cos of some function of t, we've got to actually differentiate this bit within the bracket as well. And if we differentiate pi over 26t, remember pi over 26 is just a constant, so if we differentiate pi over 26t, we will get pi over 26. So this is our solution here. Your answer here is minus 22,500 pi over 26 sine pi over 26t. Okay, so let's move on then. We're going to look at part D here. It says use calculus to show that the revenue is increasing 30 weeks after the beginning of July. Now this is a cosine function, so the function is going to increase and decrease and increase. It's periodic as well. It's going to go up and down, and increase and decrease. So when the function is increasing, so it's like this, all the tangents here will be positive at any particular point. So these tangents here will all be positive. So we've differentiated the function up here. So this part here will give us the all this thing here will give us the slope of any tangent at any point along the x-axis, or the t-axis in this case. So all we've got to do is put 30 weeks in here instead of t, see if the slope is positive or negative. So let's do that. Now we have, I'll just write that down again, r dash t is equal to minus 22,500 pi over 26 sine pi over 26t. Okay, so that's what we got when we differentiated our function. Now we want t to be 30 weeks, yeah. So we want or dash 30. So we're going to do minus 22,500 pi over 26 sine pi over 26 times 30 over 1 if you like. Okay, and you're going to work this out then. So when you work that out, I've done this, again it's just calculator work. Again, make sure your calculator is in radian mode. So your answer here is 1,263.436,359. Okay, this is positive, so this is greater than 0. So that implies then that the graph is, or revenue if you like, is increasing at t is equal to 30 weeks. Okay, and that's it for part D. So let's have a look at part E. Part E, find a value for the time t within the first 52 weeks when the revenue is at a minimum. Use or double prime t here to verify your answer. Okay, so in this case we're going to use or dash t again. That again was minus 22,500 times pi over 26 sine pi over 26t Okay, let me just double check what I've done back here. Yep, that's fine. Okay, so this is our differentiated function. Okay, so we want to find a value for the time t within the first 52 weeks when the revenue is at a minimum. So when our function is at a minimum, this differentiated function will be equal to 0. The slope of the tangent at the minimum or the maximum will be 0. So what we've got to do is let this equal to 0. So we're going to take minus 22,500 pi over 26 sine pi over 26t. I'm going to say that's equal to 0. Now let's just keep working on this. Now you can see here, if I divide across by this number here, if I divide the left hand side by this number here, it will give us 1 and disappear if you like. It will give us 1. The right hand side will still have 0. Also, if I divide across by pi over 26, pi over 26 again is just a number, so if I divide both sides by pi over 26, it'll disappear from the left hand side, or at least give us 1 on the left hand side, and on the right hand side we'll still have 0. So really, if I divide across by these two terms here, on the left hand side I should just end up with sine pi over 26t, and on the right hand side I'll have 0. Okay, so we've got to solve this. Now again, if you look at your unit circle, it's in your tables, or if you want to know where sine is 0, you know, this kind of diagram is in your tables here, where you have a unit circle, and any point along here, that's 1 unit up along here, will be cos theta sine theta. And you can see that this point here then is going to be 1, 0. It's a unit circle. This will be 0, 1. This point out here will be minus 1, 0. This point down here will be 0, minus 1. So the first term, the x term, will be the cos of the angle, and the second term will be the sine of the angle. So we can see here we have two angles here where sine is 0. So we have this angle here, I'll just put it in here, this angle along here, which is 0, has a sine of 0, you can see it here. Also this angle out here, so this angle out here from here to here also has a sine of 0. So our two angles, that would mean effectively that pi over 26 times t will be equal to the angle 0, and if you like, pi over 26 t is equal to, in terms of radians, it's just pi. Okay, so we've got to work these two out then. Well, in this particular case we have, you can see divide both sides by pi over 26, you get t is equal to 0. So at time equal to 0 there is, what was the actual question? Find the value of the time t within the first 52 weeks when the revenue is at a minimum. So at time 0 you will have minimum revenue. Also then we just need to solve this, so this is t is equal to pi divided by pi over 26 or multiplied by 26 over pi, so there's pi over 1 here, so that will just simply give us t is equal to that, and that will disappear and we just get 26 weeks. 26 weeks here. Okay, so the question was find a value for the time t within the first 52 weeks when the revenue is at a minimum. And it says then use second differential then to verify your answer. So our time is 26 weeks. I'm going to use 26 weeks here. Now we got to differentiate this function again. So again, remember r prime t was equal to minus 22,500 pi over 26 sine of pi over 26 t. Okay, so this was our differentiated function, differentiated once. We're going to differentiate it a second time, so we're going to do this. Now again we have this constant at the beginning here, so we're just going to write that out again, 22500 pi over 26. Now if you differentiate sine you get cos, so I'm going to end up with a cos here, pi over 26t, and because I have a function of t in here, I've got to differentiate what's inside a bracket as well. I've got to use the chain rule. So if we differentiate pi over 26t, we get pi over 26, pi over 26, no t there of course. So you got pi over 26 squared here if you like. Now, so this is equal to just minus 22,500 pi over 26 squared cosine then of pi over 26 t. Now at what we were asked to do initially here was find a value for the time t within the first 52 weeks when the revenue is at a minimum. So within the first 52 weeks here we're going to be looking at t is equal to 26 weeks. So or 26 here, double prime 26, is going to be equal to minus 22,500 pi over 26 squared cosine pi over 26 times 26, which is very handy. So if you look at this here, you'll end up with minus 22,500. Here you got pi over 26 squared. Here we end up with just simply the cos of pi. Our 26 will disappear here. We'll just get 1 when we divide them. So the cos of pi, again remember, Again, if you look at your unit circle, we're looking at this angle here. This is pi, and on our unit circle here our point was -1, 0. So remember the x value was the cosine, the cos. So really this just becomes -1 here. So you can see here that we have minus 22,500 times -1, so that just becomes 22,500. Our pi over 26 is squared. So all of this is positive. This here is positive. So this is greater than 0, which implies a minimum. So at 26 weeks, revenue is at a minimum. So at 26 weeks, revenue is at a minimum. And if you take, I guess if you look at the 26 weeks, it's roughly 4 months from the beginning of July, August, September, October. You're looking at coming into the winter at that stage. So people are, well, in Northern Hemisphere anyway, and the people are not going to be buying air conditioners maybe at that time. So that's really it, I think. Let me just double check the question again just to make sure. Find a value for the time t within the 52 weeks when the revenue is at a minimum. So we picked 26 weeks here. We got 26 weeks. We did a second differential, and we found that when we put 26 weeks into our doubly differentiated function, we got a positive value. We ended up with this positive value here, and that means that at 26 weeks we're looking at a minimum. And that's it for this particular question.